The average pinball machine has a length of 130 centimeters on a slope of 6.5 degrees from the x-axis. A pinball weighs 0.082 kilograms, and when you pull the spring all the way back it takes the ball 0.2 seconds to travel across the length of the pinball machine. For part A, find the spring constant. For part B, find the velocity of the ball after you missed everything in the machine and couldn't hit the ball with the bumpers. For part A, there are two parts. First, find the gravitational energy that the ball will have at the highest point in the pinball machine. Since the gravitational energy is mass times gravity times height, the equation becomes 0.082 times 9.81 times 1.3 sine of 6.5, which equals 0.225 joules. The second part is finding the spring constant. For this, use the energy equation of a spring. 1/2 times the spring constant times the distance squared. Plug in 1.3 sine of 6.5 for the distance and set the energy of the spring equal to 0.225 and solve for K. You get 20.79 newtons per meter. For part B, there are two equations used. One is the kinetic energy formula, 1/2 times mass times velocity squared, and the other is the gravitational potential energy, mass times acceleration due to gravity times height. By setting these two equal together, they equal the law of conservation of momentum. When both of these are equal to each other, the mass of the object cancels out. Since we want to find the velocity of the pinball, solve for V, and the answer should be 2.34 meters per second.